A river cut down the rock. A river cut down the rock not because of its power, but because of its continuous persistence. Same persistence is required from the students for conquering any competition exam, maybe it GATE, engineering services, state services, any competition exam. The consistency is required, guys. Okay, and today what we will be doing, guys, last change in the GATE syllabus was done in 2020 August for 2021 GATE exam. I'm again telling you, last change in the GATE syllabus was done in August 2020, and that change was done for GATE 2021, which was conducted by IIT Bombay. In that updated syllabus, certain topics have been deleted, certain topics have been added. What are the topics deleted? Me and Joshi sir have made a short on that. And in soil mechanics, origin of soil, soil structure, Westergaard equation of vertical stress has been deleted, and lateral load pile capacity has been added. From 2021 till now, no year a question has been asked from this, but since it has been added, it is expected. Nobody can tell you with 100% surety. If somebody is telling, he is either joking or making you pagal. Okay, but it is expected that yes, in next 2 or 3 years a question will be coming from this. So in this particular class, guys, this is not recorded class, huh? This is the live class. In this live class, I'll be telling all about everything from zero concept. I'll be telling you this, and I'm teaching you this in the paid class. Who are the students enrolled in the BYJU'S from the first year itself? From the first year itself, for the 2021 batch, I taught them the lateral load pile capacity. Yes, in YouTube, this will be the first time you are getting this in BYJU'S GATE channel, and that is live. I guess no channel has made it live till now. Okay, recording वगैरह दिया होगा live. I'm not very sure, but nobody has taught this till now. Okay, this is about me. My name is Abhinav, having 11 plus years of teaching experience, done my MTech from IIT Delhi, got All India rank 164 in 2012. You have to score better rank than this. For connecting me, you can mail me at abhinav.negi@byju's.com, or you can join my Telegram group, that is Civil by Abhinav Sir. So guys, in this 50 mark series, we have done this phase diagram and numericals. We have done consolidation numericals yesterday. Now we will be doing this today. Okay, and tomorrow and day after tomorrow we will be doing surveying and mock test on SOM, because I have taken SOM in 50 mark series, I have taken soil, I have taken survey. So that mock test I will be taking there. Okay, so these are my upcoming sessions. This will be coming in next week, and this will be tomorrow on 11:15. This will be tomorrow in night, Chand Taron ke beech mein. Tomorrow 11:15 PM, me and Dheeraj sir are coming for how much maximum you can score if you start from today. Okay, and I hope you have seen this. This is just uploaded couple of hours back in the YouTube channel. This is just uploaded couple of hours back in the YouTube channel. I hope you have seen this. Okay, I hope you have seen this. Otherwise, you can see this is 11-minute video. You can see this later on. Okay. Let me just make it. Give me a while. Everyone, guys, come on, join fast. Okay. Keep sharing the session, guys. Okay. Keep sharing, keep sharing, keep sharing. फटाफट से चलते हैं फिर आगे. Now, government job versus PSU versus private job. This was done, and you can find all the links and important information in my Telegram group, Civil by Abhinav Sir. Already 4,900 students have joined there. You can also join it. Now, before going further into the lateral capacity of pile, I'm even going from more basic. Why foundation? If somebody asks you that what is foundation or why it is the requirement of foundation, then what you will reply? What you will reply? What you will reply? What is why foundation, guys? Our basic aim is to distribute the stresses. Okay, so whatever the load is coming in the superstructure, suppose this is the ground level somewhere here. Okay, so it will be having dead load plus live load. We have to distribute this to soil. We have to, whatever the load is, suppose some P load is of this, we have to distribute the soil. So to make it distribute, soil is not as strong as concrete, so we make a foundation with larger area. Stress is equal to force by area, so we make a larger area so that stress is reduced, and this stress should be such that it will be less, it should be less than the bearing capacity of soil, so there is no failure. Okay, so mechanical engineer deals with force, civil engineer will be dealing with stress. Okay, so we have to make a larger area here so that whatever the load is here, that can be distributed. Now next question is, what is shallow foundation, what is deep foundation? Now suppose here at the shallow depth, soil is not very strong, so either you have to make a very large area, this is ground level, either you have to make a very large area. Why large area? Because soil is very weak here. Soil at this shallow depth is very weak, so we have to make a large area. But large area karte you cannot go to the neighbor's boundary na, and cost wise also it will be uneconomical. So when at shallow depth soil is not very strong, or you have to make a large area foundation, so it is becoming uneconomical. In that case we have to go for the deep foundation, that is pile foundation. Whatever the structures, this is the pile foundation, this is the load, and piles are made. Now what is the piles are made, and it is made such that their end is at the hard strata, because soil at the shallow depth is relatively weak, so they are putting at the such that here now soil is strong, so it is getting the reaction and bearing capacity from here. Now whatever the superstructures we are, this is the piles, these are the piles. How piles is actually helping? How piles are actually helping? Suppose this is the ground level. Okay, suppose this is the ground level, and below ground level this is the pile, and load is acting from here. Okay, from the superstructure. So two types, or from two ways the pile is resisting the load. One from here, QP from the end bearing capacity. Okay, if that is put in hard strata, it is putting some load. And second is that here this P load wants to push it downward, so friction will be acting upward. Friction is opposite to the relative motion. Due to the superstructure load, this wants to go downward, so upward load will be acting, that is QF. So whatever the load coming from top superstructure will be resisted by end and will be resisted from friction. Whatever the large structures, skyscrapers are these days, like Burj Khalifa or any tall building, whatever the skyscrapers these days, even in Burj Khalifa there are hundreds of piles. This is a buttress system of Burj Khalifa. Okay, Burj Khalifa has a certain architect point of view, and that is called buttress system, something like this. Okay, and these are the piles. More, I guess 200 or 600 piles are there, which are resisting the huge load of Burj Khalifa. And the architect of Burj Khalifa has said that with this buttress system, with this core, with this structure, even up to 4,000 meter, 4 kilometer, a building can be made. But of course, in that case, there are certain drawbacks, that above atmospheric pressure will be very less. When the person is going above, he may cause dizziness, as the certain tourists feel in Leh Ladakh, because atmospheric pressure is less there. So 4,000 meter means a considerable difference in that building, which is, if theoretically that is made. Burj Khalifa is not that much. Okay, so there are some structural point of drawbacks are also, or limitations are also there, and human limitations are also there. So shall we start? Now this is the story behind it. Shall we start the lateral capacity of pile? Shall we start everybody? कहाँ गया मैं comment देखने के लिए? Everybody, shall we start? Okay, keep sharing, keep sharing, keep sharing. Now see, whatever till now in the GATE syllabus now you study is the longitudinal capacity. What you have studied, some QU load, and QU is acted by point bearing and friction, QP and QF. So you are till now for sand and clay, for individual sand pile, for individual clay pile, for group actions of piles, that is the longitudinal capacity, okay, in this direction. That is a superstructure dead load in the direction of gravity. Now the newly added topic is lateral pile capacity. Guys, lateral load can also be coming. Suppose this is the pile and this is the ground level. So lateral load can also come. Lateral load can also come. Lateral load can also come. Now lateral load can come due to various things. Now suppose is the earth pressure. Earth pressure. Okay, soil is here na. So from here earth pressure will be there. Of course, at any point in the soil, there is a vertical stress sigma V. Similarly, there is a horizontal stress sigma H also. That is Ka into sigma V or Kp into sigma V or K naught into sigma V, depending on case to case. So that thing is there. So due to earth pressure it can come. Due to the dynamic forces such as earthquake, due to the dynamic forces that are coming from the epicenter, okay, earthquake is not like this, the force is directly coming vertically above, the shock waves are coming vertically above, no. Okay, hello Priyali, how are you? So the load can come from the earthquake in any way, so dynamic forces, the load can come. Now due to the groundwater table, suppose somewhere here there is water table. So water table at this point, if the pressure is gamma WH in this direction, then gamma WH in this direction also na. Water is hydrostatic, water exerts hydrostatic pressure. In every direction, pressure is same. So due to water table, the lateral load can come. Okay, due to wind forces. Okay, so due to wind, of course wind will not be below ground level, but wind will be coming here, and that whatever the load, the wind load is exerting force on the superstructure in X direction, in horizontal direction, a bit amount of effect will be coming in the piles also. So due to that also the lateral load or it can come. Now one more thing guys, due to wind forces, earthquake and this, now one more due to soil inclination. Okay, suppose the soil is not exactly horizontal, suppose the soil is like this with a beta angle. Okay, now again the mg sin theta, okay, the weight component here, okay, that also will be providing lateral load. Now and due to दिख रहा है नीचे का, due to settlement in nearby area, settlement in nearby, okay, see suppose here it is a pile, here it is a pile, and here the load is due to some superstructure, due to some superstructure this is settled. So this is settled due to Poisson effect. See, due to Poisson effect, if it is compression here, it will be elongating here. So I am talking about this particular region of soil. I am talking about this particular region of soil. Due to this weight, if this is settled, so due to Poisson effect, it will be going to be like this. And when it is expanding like this pile, this green pile will be exerting horizontal forces. So due to various reasons, these are not, there are 10 and numerous reasons other, due to which the lateral load will be coming. Okay. Now, up to now, if somebody asks you that, yeah, this is the pile, this is the dimension, this is the material, what it can carry the load, what you do? QF plus QP. But that load is in the longitudinal direction. If somebody asks, yeah, this is the pile, this is the diameter, this is the length, this is the material, how much horizontal load it can carry, you don't know till now. Now, this particular session is about the horizontal loads. Okay. Thank you Priyali Sharma. So this is never I taught, you can see this. Okay, now for lateral capacity of pile, various models come. Now first one is the Winkler's model. What says this? If there is a beam and you apply load, then deflection at every point will be different. Deflection at every point will be different. It says P is equal to KH and P is equal to K delta, and you can assume this. You can assume this slab to be supported. You can assume this slab to be supported in various springs. Okay. You can assume this slab to be supported in various springs as delta P is equal to K delta, and as delta at every point is different. As delta at every point, here delta is something else, something else, more delta, less delta, less delta, less delta. As delta is different, so K will also be, stiffness will be different at every point. Where the deflection is less, if you are assuming this soil to be spring, if I am assuming this soil to be spring, that soil will be having higher stiffness. Now here, if I am assuming this soil to be spring, this is ground level, hai na? So if I am assuming this soil to be spring, here deflection is more. So here, if I am assuming this to be spring, here K will be less because deflection is more. At ends, deflection is less. So if I am assuming that soil to be spring, K is more. So what it says, Winkler's model, assume every soil to be spring. Spring analogy, we say this. And assume every soil to be spring and find the stiffness at every location. Due to same thing can be done in lateral pile capacity. When the pile is like this, you are applying the load like this. Now in this case, if you assume this part, these all soils to be spring, you can find that from the stiffness value that how much load it can carry. But Winkler's model is not adopted and the questions will not be coming from here. Winkler's model is not adopted and the questions will not be coming from here. Guys, keep sharing the session and please hit the like button. Everybody give me yes or no in the comment section. I'm audible and visible both na? Come on. Come on. We'll complete it today. Okay. Everybody on the comment section. Now, but Winkler's model, the question will not be coming. Now another is Terzaghi. It says that P is equal to K into H or P is equal to K delta. It says that P is equal to K delta. The load will be K into delta. And how to find K? He has called this KH, modulus of subgate reaction. He says that there are two methods for finding the K. One is that whatever that pile is, draw a P delta curve. Apply the load and see what is the deflection. Apply the load. You are not applying the load in the pile which is below a house or below a building. When you are in testing phase. In the testing phase, insert that pile in a location and load the pile in horizontal direction and find the deflection. Load the pile and find the deflection. We are in testing phase. We are not in construction. So there might be some curve like this. Now initial tangent will be the KH. Initial tangent, draw the initial slope, that will be the KH, okay, and here draw like some other 2 points. This will be the secant modulus, not second modulus, this will be the secant modulus. Now how much load, if anybody asks this is the pile, how much load you can apply, the answer will be the load you can apply is KH into delta. Now what is KH? If the load is less than 1/3 working load, okay, working load means which is about to come in the building. If load is less than 1/3 working load, you have to take this KH initial slope, and if load is greater than or equal to 1/3 working load is the load which is about to come, in that case take the secant modulus, whatever the slope of coming here in that case. Now again this Terzaghi, that is also not mostly widely adopted, because here what is delta? What is delta we have to take? We don't know anything about that. So now the class is starting from here. Now the class is starting from here. Class starts on whatever I am teaching you till now, all is rubbish, is not coming in exam. I am just telling that lateral capacity before Terzaghi has given some theory for lateral capacity of pile but not widely adopted. Winkler's has given some theory but not widely adopted. Now what is widely adopted is Matlock and Reese theory. So first of all, Matlock says that there are two types of pile. One is free head pile. and another is fixed head pile. Another is fixed head pile. Okay, now what is free head pile and what is fixed head pile? Can anybody tell me on the comment section? कुछ तो बोलो भाई. What is free head pile and what is fixed head pile? Okay, no? Okay, let me tell. Okay, no worries, no worries. You might be studying this first time. Now see, the free head pile is, suppose this is a pile and and this is the ground level. This is the ground level and you are applying some load on this. You are applying some load on this. Okay, this is the lateral load. Vertical load के बारे में बात ही नहीं करनी है. That we have studied already. Now, if the deflection is something like this, that is free head pile. What is fixed head pile? After that only you will understood the free head also. Suppose this is the ground level. In this ground level, suppose this is the pile. In this pile, suppose you are applying some lateral load. In this pile at the ground level, you are applying some lateral load, and its distribution is like this. Okay, and its distribution is like this. Fixed head pile, here the slope at the ground level of the pile is equal to the initial slope. If initial it is making 90 degree to the ground level, then again it is making 90 degree, that is fixed head pile. That means, like in fixed head, slope is 0. In fixed cantilever beam, at fixed support, slope is 0. So here, whatever is the slope initially, it has not changed. From vertical line, still the angle will be 0, or from horizontal, it will be 90 degree. Okay, but here some slope is changed. Earlier it was some different angle, now it is some different angle. That is free head pile. Now, whatever the Matlock, I will be telling you the theory. Whatever the Matlock, I am giving you the theory. That Matlock theory is only applicable. That Matlock theory is only applicable for free head pile. This many will not tell you. This many people will not tell you. Matlock theory is only applicable for free head pile. But for free head pile, long piles, free head pile. But we will apply for fixed also with slight modification. With slight modification, what is that modification? I'll tell you at the end. With slight modification, we can apply this. We can apply for fixed head pile also. What is that modification? We'll see later. Today only. With slight modification, we can apply this for fixed head pile also. Okay. Now, moving further, everybody. Okay. Guys, keep sharing the session so that more and more students can get benefited. Everybody. See. Now, what is going to be here? Please everybody see. In fixed head pile. Please see here that suppose this is our pile, है ना? And this is suppose ground level. Okay. And in this ground level, what we are doing? We are applying, suppose load at the ground level is QG. QG is represented, G is represented ground. QG is the lateral load at the ground level. And there is some movement also. Mg, movement at the ground level. Okay. Due to QG, that is load at the ground level, and due to Mg, their movement at the ground level, this pile is going to be suppose something like this. And the deflection at the top or at any point is Y. Deflection at any point is suppose Y. At any Z depth, deflection is Y. Now, from the principle of superposition, what we can do, this is the pile, okay, this is the pile, and here the load is acting at the ground level and movement is acting at the ground level. So due to load, we will find different analysis. due to movement we will find different very things, due to load and due to movement. Due to load and due to movement there will be different like this deflections like this, and suppose here at any point the deflection is YA and here the deflection is YB. Okay, YA due to load, YB due to movement, YA due to load, YB due to movement. So total Y is equal to YA plus YB. Total Y, total deflection is YA plus YB. Now what is YA, YB I will tell you. But before that, what are the things we want to find out? Analysis of laterally loaded pile. Analysis of laterally loaded pile. क्या क्या निकालना है, क्या क्या निकालना है हमें, क्या क्या टॉपिक इसमें पढ़ने, क्या क्या टॉपिक इसमें पढ़ने. ठीक है, ये भी देख लें जरा कि भाई क्या क्या टॉपिक पढ़ने. ठीक है, एवरीबॉडी जल्दी बोलो. यू आर गेटिंग माई वॉइस, यू आर गेटिंग माई वॉइस. फटाफट से फटाफट से. ओके ओके, कोई दिक्कत नहीं. कहाँ गया मेरा सेशन? ओके, कीप शेयरिंग गाइस, कीप शेयरिंग. ओके, तो इसके अच्छा हमें क्या क्या पढ़ना है. एक तो हमें निकालना है डिफ्लेक्शन, एक तो हमें निकालना है यहां पर डिफ्लेक्शन, डिफ्लेक्शन. एक हम निकालेंगे मूवमेंट, एक हम निकालेंगे शियर फोर्स, एक हम निकाल लेंगे स्लोप. नीचे दिख रहा है अभी भी. डिफ्लेक्शन, मूवमेंट, शियर फोर्स, स्लोप निकाल लेंगे. ठीक है, डिफ्लेक्शन निकालना है एट वेरियस जेड, है ना. स्लोप, मूवमेंट, शियर फोर्स एंड सॉइल का रिएक्शन, सॉइल रिएक्शन. बॉटम बार से छुपतो, हाँ ये सब निकालना है, ये सब निकालना है. और एक निकाल लिया सब निकलेंगे. व्हेन वी फाइंड वन विल फाइंड अदर्स आल्सो, डोंट वरी. डिफ्लेक्शन एट z इज इक्वल टू 1 मीटर, z इक्वल टू 2 मीटर, z इक्वल टू 3 मीटर, z इक्वल टू 4 मीटर, z इक्वल टू 5 मीटर. मूवमेंट एट 1 मीटर, 2 मीटर, 3 मीटर, 4 मीटर. शियर फोर्स एट 1 मीटर, 2 मीटर, 3 मीटर, 4 मीटर. स्लोप एट 1 मीटर, 2 मीटर, 3 मीटर, 4 मीटर, 5 मीटर, 6 मीटर, or whatever, 2.2 मीटर, 2.26 मीटर, whatever. Okay, so we have to find this. Now y is equal to ya plus yb. Now see what Matlock and Reese has given, that y is equal to ya plus yb. Now that ya and yb, let me tell you, ya, that is low deflection due to ground level, that y is equal to qg into t cube upon E, that is Young's modulus of elasticity, upon I is the moment of inertia of pile material, into ay plus, ay is a coefficient, this is ya due to load. Due to movement it is mg into t square upon ei into constant by. Ay and by will be given guys, ay and by will be given, ये गिवन होंगे आपके पास. ay and by you will already be knowing. Okay, qg t cube ei into ay is a constant, mg t square by ei into by. Now what is t? Now after that the question will be what is t? Now see, t is equal to e into I upon eta h की पावर 1/5. ei into eta h, somebody write its k also, की power 1/5. Okay, E is the Young's modulus, I is the moment of inertia, and eta h is the unit modulus of subgate reaction. Eta h is equal to modulus of subgate reaction, modulus of subgrade reaction. Okay, eta H unit will be kilonewton per meter cube. Kilonewton per meter cube, and unit of T will be meter. And you can verify this also, yaar. What is unit of E? Young's modulus is kilonewton per meter square. What is I? Meter ki power 4 divided by what is EH? Kilonewton per meter cube. Okay, ki power 1 by 5. So what is this? This will be kilonewton meter square, meter ki power 5 into 1 by 5. This will be meter only. This will be meter only. Okay. So T is the relative stiffness. T is equal to relative stiffness. T is equal to relative stiffness. Let me write it clearly. This is a better writing. Qg into Tq upon EI into AY plus mg into T square by EI into BY, and the value of T is eta EI. This is EI. This is EI. Young's modulus into moment of inertia upon eta h ki power 1 by 5. T is the relative stiffness. Eta is modulus of subgrade reaction. Subgrade reaction, I already told you. Unit is kilonewton per meter cube. T has a unit of 5. If L length is greater than 5T, then it is long pile. L is less than 5T, it is short pile. And Matlock and Reese theory is not exactly, whatever the deflections you are getting now from here, this is deflection due to ground level load, this is deflection due to ground level movement. This will not be exactly same with 0% error with the real values. This Matlock and Reese theory are very near to the Reese value. Actually, these are not some derivable formulas that I can derive for you. These are based on certain assumptions. So they are very close to the real values, and in fact, for the long pile, they are more closer. If I have to compare that, whatever the values you are getting here, they will not be exactly same as the real situation, as the real deflections. But they are more closer, and for long piles, it has been observed that they are much more closer than the real values than if we comparing with the short pile. Okay, AY and BY are constants, and T is equal to EI and T is the relative stiffness. AY and BY value will be given. Okay, we'll do a numerical also. We'll do a numerical also. Everything will be given. Everything will be given, and AY, BY will be given. In fact, for if you find the books now, for different value of Z, AY and BY values will be given. Okay, Z is equal to 0. What are the values? Z is equal to 0.1. What is the value? Okay, suppose you want deflection at Z is equal to 2.2 meter. So from here 2.2 meter, what is the AY, BY? Put that AY, BY here. Then the deflection you will be getting for corresponding to that Z. Z means depth. So for different depth, AY and BY will be different. So whatever, at what depth you want deflection, corresponding AY and BY you have to put here. Okay. Now this is about the deflection, and deflection is most probably it will be coming. Otherwise, if you want not deflection, if you want movement, now what is movement? Guys, I hope you remember Som, in double integration method I told you, it is EI d2y by dx2. Okay, d2y by differentiated 2 times. Okay, m is equal to EI d2y by dx2. Or first of all, even before m, let us find slope. Even for m, let us find slope. Slope is dy by dx. So differentiate it. So qg t square. It will not be 3t square, because the real values are not coming with 3. It is coming with t square. It has been observed. There is no derivation that I can tell you that why I have done t cube differentiation is t square. Why I have not done 3t square. Okay, that 3 will be coming in the constants given by Matlock and Reese. There is no derivation for that. Okay, this is just a process that in which you can learn. Okay, this will not be 3t square, because 3 लगा के उन्होंने देखा होगा. भाई theory है ना, theorem law और theory में समझते हो difference. This theory, law is universal. Theorems are proven, exactly proven. Theory is based on certain assumptions, not closest. Laws, Newton law, gravitational law are universal. Or theorem are proven, exactly proven. But theories are not proven. Okay. So it is not 3t square, it is t square upon EI, and some different slope will be coming AS. plus differentiate again with T, mgt upon EI into BS. This is slope. This is slope. Okay. Now movement. Now movement is d2y by dx2. Differentiate 2 times and one more EI. So one more EI will be cancelled from this. So differentiating 2 times, so it will be qg t into movement am plus mg differentiation will be mg. EI will be cancelled na. M is EI into d2y by dx2. When EI is multiplied, this will be cancelled. So mg into bm. Give me yes or no. Give me yes or no, everybody. It will be qg t into m mg bs plus shear force. Shear force is dm by dx. So differentiating, it will be qg into av mg into t ki power 0. Just a way of remembering. They are not derivable. mg into t ki power 0. So t ki power 0 will be mg by t. Differentiation of x ki power n is x n minus 1 na. So t ki power 0. So 0 minus 1 is 1 by t. Otherwise it has to be, if you differentiate with t, it will be 0. But this is the process of remembering. I already told na, this is theory, not law, not theorem that I can derive. Okay, on certain assumption it has been seen कि 0 देख के आंसर नहीं मैच कर रहा होगा practical results. So देखा कि mg by t करके कर रहा है into av, and 5 things are asked na. 1 2 3 4 5. So what we have find out y 1 2 3 4, and now load, that is soil reaction, w or soil reaction. Okay, again differentiate with t. So it will be qg by t into AW, AV constant. These are all constants. It should be BV. And mg t ki power minus 1. T ki power minus 1 differentiation will be t square into BW. These all constants value will be given at different. AY, BY are given at different Zs. AM, BM are given different Zs. AV, BV are given at different Zs. Okay. For whatever Z you want, shear force, movement or load, accordingly you can find. Okay. So this is most expected that this will be coming. Why? Okay. Have you understood? Have you understood? Okay. Now, let us take a question, guys. This one. Please. If you want some, what is asked? What is relative stiffness? Relative stiffness, if you forget the formula, E into I into eta h, modulus of subgate reaction, की power 1 by 5. Please do it and let me know the answers. Please do it and let me know the answers. Please do it and let me know the answers. Do it and let me know the answers. आ गया सबका? How much is coming? What is E? कहाँ है? E is 3 into 10 की power 7 kilonewton per meter square. What is I? कहाँ गया? Concrete pile 50 centimeter square, 0.5 meter, point BD cube by 12 divided by eta h, 2 into 10 की power 4 की power 1 by 5. Okay, and this will be coming 1.5. Please check. Please check. Please check. Okay. Now, guys, one more thing I want to tell, that all these formulas na, note, all previous formulas are for free head pile. free head pile. If pile is fixed head, if just replace, in that case you have to just replace QG mg by 0.93 g cube, mg by 0.93 qgt, mg by 0.93 qgt. Okay, whatever, wherever the mg is coming, 0.93 gqd, 0.393 gqd, 0.93 qgt, 0.93 qgt, and then formulas are same for fixed head piles also. Okay, now after this, let us, this is the same question, same values means T will be 1.5, same values means relative stiffness value will be 1.5. okay, relative stiffness value will be 2.5. If the pile is considered to be free head pile, now then the maximum deflection will be, so y is equal to ya plus yb. Ya is the deflection due to load, so it will be qg t cube into ei into ay plus mg into t square upon ei into by. Okay, this is qg t cube ei upon ay plus mg t square ei by. Every value is given. Every value is given. You can easily find out. You can easily find out. You can easily find out. Every value is given ना यार. Two ay and by are given. Okay, किसी भी z का है उस z के corresponding this is given. What is qg? Qg is 5000 Newton. What is mg? This convert in Newton meter for everything to be SI unit. Put it E and I. It will be coming. What is this? Suppose this you put in Newton. Okay, this you put in meter. This you put in Newton per meter square. This in meter ki power 4. T is meter, so T cube will be meter cube. So it will be coming meter cube, meter square, meter. Yes, this is coming meter. Excellent. Answer will be in meters. Can put in everything in these units, it will be in meters. Similarly, mg, put in Newton meter. This is kilonewton meter, convert in Newton meter by multiplying thousands. Then T square will be meter square. This will be Newton per meter square. You can convert here. This is meter ki power 4. By has no unit. So this will be Newton per meter square, meter square, meter square. It will be again meter. Yes. From here also it will be meter. So every value is given. E, I, every value is given. You can find the answer. Every value is given. You can find the answer. This MSQ I am giving homework, and you can ask me on mail ID abhinav.negi@byju's.com for the solution. For the solution you can find me. Okay, just take a screenshot. Giving you 3 seconds. 1, 2, 3. 1, 2, 3. I hope you have taken the screenshot. Okay, so you can join me in my Telegram group, Civil by Abhinav sir. And this after 10 minutes, everybody, I want you here in app from 10 PM today. 10 PM today. Okay, the link will be in my Telegram group. Link will be in my Telegram group. Please do watch this video. This is 11-minute video. I just uploaded today. You can see this. And now we are meeting tomorrow here, surveying class. Okay. And these are the sessions as I already told. This we are coming 11:15 PM tomorrow night. Thank you guys. Take care. I hope you enjoyed the session. Thank you all. Take care. Good night. Thank you.